Afternoon. Welcome to Insight Engineering Hub. Insight is a premier provider of professional engineering development courses, and today we're going to present a course on professional engineering ethics. It'll be given by myself. My name is Stephen Vitale. I have over 50 years of experience in the gas industry, and I'm presently a consultant and I'm going to be verbatim stating many of the attributes that are given by the National Society of Professional Engineers, the National Council of Examiners for Engineering and Surveying, and the Accreditation Board for Engineering and Technology. So some of the information I'll be presenting will be written and read aloud, but it's being read because it's verbatim from these governing. I had a call all day except just now. Let me just shut the sound on that. Okay, I'll be reading the codes of conduct that from the NSPE and the NCEE and the Accreditation Board. A professional adheres to ethical standards, demonstrates competence in their field, very interesting point, in their field, and is committed to continuous improvement, which is what we're doing right now. They maintain a high level of responsibility, accountability, and integrity in their work. We'll talk about many places where integrity comes into the work that you do as a professional engineer. A man who walks with integrity is unwavering in his principles, acts with honesty and fairness, and earns the trust and respect of others through consistent behavior. And we will discuss that in many aspects. The preamble of the NSPE, that's the National Society of Professional Engineering. This engineering is a profession that directly impacts the quality of life for all people. Engineers must exhibit the highest standards of honesty, integrity, and dedication to protecting the public health and safety and welfare. That public health, safety, and welfare, if you look at all the things that we discussed today, it always comes back to protecting the public, providing safety, and providing for their welfare. There are six fundamental canons that are prescribed by the NSPA. These six canons are as follows: hold paramount the safety, health, and welfare of the public. And you'll see that the other five go back to this holding paramount the safety, health, and welfare of the public. Perform services only in your area of competence. We'll talk about some case studies related to that. Issue public statements that are truthful, and I'll give some examples of that. Act as a faithful agent for clients. We'll give some examples of that. Avoid deceptive acts and act in with conduct that enhances the honor and reputation of your profession. Rule number one, public safety. Engineers must hold paramount the safety, health, and welfare of the public. In their judgment, if their judgment is overruled in a way that endangers life or property, that's the professional engineer, must notify their employer or relevant authorities. Now, all relevant authorities may mean going outside of the company frame and actually giving a whistleblower. We'll give some examples of that. Although that's not very popular, it may be required. Rule number two of practice. Rule of practice number two is competence. Engineers must only perform services in their area of competence. They cannot sign off on work that they are not qualified for or did not supervise directly. Rule of practice number three, public statements. Engineers must make public statements that are objective and truthful. They should provide relevant information in reports and in testimony and avoid misleading statements. I'll give you an example of a misleading statement that occurred, and as being part of a case study. Rule of practice number four, being faithful agents. Engineers must act for their employers or clients as faithful agents, disclosing any potential conflicts of interest. They must not accept compensation from multiple parties unless all parties are informed. Rule of practice number 5, avoidance of deceptive acts. Engineers must avoid deceptive acts, such as misrepresenting qualifications or exaggerating past accomplishments. They must not engage in any form of bribery or dishonest conduct. Rule of practice number 6, conduct that enhances the honor and reputation of the profession. You're a professional engineer, a professional surveyor. Your ethical conduct goes beyond your immediate activities in your engineering job to include other activities that could discredit your reputation or discredit the reputation of your profession. For example, you cannot engage in racketeering as a second job. That's an obvious one, but there are some gray areas as well. Professional obligations. Engineers must be guided by honesty and integrity in all professional relations. They must acknowledge errors, avoiding conflicts of interest, and treat all persons with dignity and respect. And this speaks specifically to if you come into an engineering culture where sexual harassment and disrespectful treatment, racial comments, etc., are commonplace, you cannot become part of that culture. Perform engineering that develops sustainable development. Engineers should adhere to principles of sustainable development to protect the environment for future generation. This includes designing systems that meet human needs while conserving natural resources. Reporting violations, and here's a sticky point for many engineers. Engineers who are aware of violations of the code of conduct or the code of ethics must report them to the appropriate authorities. This is essential to maintain the public trust and upholds the profession's ethical standards. Case study integration. We're going to be doing some case study integration and looking at a number of different events that have occurred. In reviewing case studies such as the Challenger disaster and the Hyatt walkway collapse, and we'll look at both of those, we see clear violations of the NSPE guidelines. These examples demonstrate the critical need for engineers to adhere to ethical standards. In summary, the ethical practice in engineering. Ethical practice is the cornerstone for engineering profession. Engineers must prioritize public safety, adhere to ethical standards, and commit to a lifelong professional development, which is part of what you're doing right now. By maintaining ethical integrity, engineers can ensure the trust and safety of society. Future trends in engineering ethics. As technology advances, engineers will face new ethical challenges, including ethical implications of AI, cybersecurity, biotechnology. Engineers must continue to adapt and apply ethical principles to emerging fields to ensure that their work benefits society and protects the public. And each of us can look back on our careers. My own career is over 53 years actually in the gas industry. I can see how much technology improvements have occurred over the past 50 years and how they have affected the way I work and the way I provide services to the public. Technological advancements and ethics. The rapid advancement of AI and robotics introduces new ethical concerns. Engineers must address issues of bias, privacy, and accountability when designing and implementing these technologies. We probably all applied AI to our work, whether we realize it or not. In some way or another, we've applied AI to our work. And in doing so, we need to realize that AI is an emerging technology that could have significant beneficial impacts on society, also could be some negative impacts. So we have to use it prudently, make sure that the biases, or if there are any biases built into the AI, that we recognize those and avoid the biases, and that we certainly provide privacy and accountability in all that we do. When I mentioned privacy, realize that As an engineer, we may have records or documentation from our clients. Well, the same level of prudency that the client takes on protecting those confidential documents, we have to take in storing those confidential documents. We need to ensure that technology serves the public good. Cybersecurity and ethics. As cybersecurity becomes more critical in modern engineering practices, engineers must make steps to protect data, ensure privacy, and prevent malicious use of technology. Ethical frameworks guide the responsible behavior in the digital realm. As we use AI and other technologies, we have to be certain that we're using them properly and that we're not setting up a system that provides a platform by which others can use those technologies in a negative way. Global impact of engineering ethics. Engineering decisions are getting more and more global in their effect as they affect not only local communities, but also international environments, economies, and societies. Ethical practices contribute to the well-being of the planet as well as the well-being of our local area. Public health and safety in engineering. Again, that is the first thing I brought up in this presentation. Ethical obligation for engineers is to protect the public health and safety. And everything that we do, you'll see how it goes back to this one thing, public health and safety, whether it be our statements to the public or whether it be our conduct, it all goes back to ensuring public health and safety. Keeping a strong reputation as an engineering professional is exceedingly important. And we'll cover some examples that show that. The role of professional organizations. What are the professional organizations? Well, two of them in particular are the National Society of Professional Engineers and the National Council of Examiners for Engineers and Surveyors. These organizations set ethical guidelines for engineers and enforce standards of professional behavior. These organizations do not give and take disciplinary action. That is done by your local state authority. But these organizations set the guide, set the benchmark for what is considered ethical performance. These organizations provide critical oversight, ensuring that engineers act with integrity and accountability in all aspects of their work. The future of ethical engineering. As engineering continues to evolve, the need for ethical practice will remain constant. Engineers must commit to upholding ethical standards, ensuring safety and well-being of society, we'll go back to that, and addressing new ethical challenges that are posed by emerging technologies. Professionalism cannot exist without ethics. Every day you will make decisions. Your zero tolerance of unethical behavior needs to be a daily highest priority. Only you can make your decisions, and sometimes they'll put you in uncomfortable situations. NSPA Code of Ethics. Engineers must adhere to professional obligations as outlined by the Code of Ethics, which I reviewed. In summary, it's honesty and integrity in all your professional dealings and also outside of your professional dealings. Acknowledgement of errors and prompt correction of those errors. Avoidance of conflict of interest. Sustainable development in engineering. Engineers have a responsibility to design systems that meet the needs of the present day without compromising future generations. Sustainable development includes minimizing environmental impacts and conserving resources. And often those are a judgmental or a vague area, but it's something that you need to consider whenever you're designing anything that's going to be used and by the public, for the public, or any infrastructure that's going to support the public. Ethical responsibility in emerging fields. I mentioned such things as AI, but there's also nanotechnology and biotechnology that are emerging. These must be applied with ethical principles to address these new challenges. These include issues of privacy, data security, and societal impacts. ABET is the accreditation body that accredits universities and educational institutes. They set the standards, ethical standards in education. ABET sets ethical standards for engineering programs, ensuring that students are prepared for ethical challenges of professional practice. Programs must teach students to recognize and resolve ethical dilemmas. I don't think this was as pronounced in 50 years ago in my engineering college review, but it's certainly, I'm on a college board right now, and it's certainly a major concern that we abide by the ABET ethical standards for engineering programs. It allows your university or your educational institution to be accredited by ABET. ABET criteria, ethical responsibility. ABET criteria focuses on ethical and professional responsibility. Engineering students must learn to make informed judgments that consider the impact of engineering solutions on society, the environment, and public safety. Let me go back to the public safety again here. ABET criteria also involves continuous improvement. Criteria ensures that engineering programs continuously assess and improve student outcomes in ethics. This promotes a culture of lifelong learning and adheres to ethical standards. You can see what we're doing right now, continuous learning. And you're required to have so many continuing education credits for your renewal of your license. Well, part of the ethical criteria is that you report on those PDHs, professional development hours, and that you report on them accurately and honestly. Future trends in engineering ethics. The rapid advancement of technologies presents new ethical challenges for engineers. These include ethical implications of AI, cybersecurity, and autonomous systems. I had not mentioned that yet, but that's coming up. Autonomous systems are becoming more and more prevalent in technology and in the engineering field. Artificial intelligence presents a significant ethical challenge. As you've seen in the past year, AI has really entered into the technology in a significant way, and it'll probably be much more in 2026, this new year that's going to start in about 4 days. Maintaining accountability for AI-driven decisions is critical. Protecting privacy and data security in AI applications is also critical. Some AI can be misused and not for public good. You need to be conscious, aware of that, and making sure that you're not allowing that to be encouraged on whatever platform you're providing to the public. Cybersecurity and ethical challenges. We kind of mentioned this, so I'm not going to go over it here at this point in time. But key to that is safeguarding the public. Global impact, I mentioned some of that as well. And we understand how more and more our activities are not only affecting our local community, but also has a global impact across the globe and what we provide in engineering services. Sustainability and environmental ethics. We spoke mostly about that, so we got that pretty much covered in the general. We're going to look at that in some of our case studies. Case studies. Very important case studies that we're going to be reviewing. One of them is the Challenger disaster. The Challenger disaster is a powerful example of the consequences of ignoring ethical responsibilities. Engineers must learn from this case study and other case studies to prioritize public safety over external pressures to meet deadlines and budgets. In the Challenger case, in the case of the Challenger disaster, I should say, there was high pressure being put on the engineers that were involved with the design of the booster rockets. And some of the engineers spoke up and said, these O-rings are not intended for cold weather operation. They're not designed for that, and they could fail under cold weather applications. And the day that the Challenger was to take off, the weather was colder than what these O-rings were designed for. The engineers spoke up to their management, but their management overrode them, and the launch took place. And as a result, 7 astronauts were killed, and tremendous loss of hardware was incurred. And aside from the loss of hardware and the loss of these 7 persons, or 7 people, I should say, the engineering profession took a hit because here we had professional engineers that knew, I don't know if they were professional engineers, but they were certainly engineers. I assume some were professional engineers that knew of the potential hazard, the potential risks that was associated with a takeoff occurring in cold weather. They warned management, but management had pressures of meeting deadlines, meeting budgets, looking good before the public because the flight wasn't delayed again, and they overrode their subordinates. And in doing so, we have the challenge of disaster. Now, what does the NSPE guidelines say? Well, they authorize or they encourage whistleblowing. You may or may not agree with that, but that is part of the message here for ethical engineering. That if you see something that's being overridden, that's going to cause public harm and cause an unsafe condition for the public or for individuals or hardware, you need to be able to speak up to the proper authorities. Let's look at the case study of the Hyatt Regency walkway collapse. There was a good design made for the Hyatt Regency walkway. The design was to have these steel rods come down from the roof, and each walkway was to have a washer and a nut screwed up all the way from the bottom to this point here, and that was to hold this walkway in place. And there were many such rods all around the Hyatt Regency that was supposed to be installed that way. A field change was made, and the field change was, okay, we're going to install the rod from here to here, put a nut in the washer, and then install another rod from here to here, put a nut in the washer on both ends, put another rod from here to here. So what's different? This looks like a harmless design change, but in reality, it's not. And here's why. Now, both this design change and this one have the same amount of stress in this rod and have the same amount of stress on this rod and have the same amount of stress on this rod. What is different though? Take a look what happens at this flange. The flange, the amount of force on this flange, now I'm just showing 1, 2, 3 balconies, now is 3 times the amount of force that would be on this nut and washer. What would happen is this flange fish-mouthed and the entire walkway collapsed. What did that cause? It resulted in 114 people died and 216 people were injured. A balcony collapse. Now, what does this have to do with engineering practice? Well, a construction project like this is overseen by engineers, and you need to enforce management of change. What is management of change? If you make a change in the initial design, it needs to be thoroughly reviewed from an engineering perspective. If this was thoroughly reviewed, this accident would not have occurred. What about the case study of the Ford Pinto? In the Ford Pinto case, the engineers working for Ford knew that there was a gas tank design was risks were ignored by management. They brought up the risks and it was ignored by management. And I forget how many people were killed. It was over 20 people were killed before this was finally addressed. And it showed this case underscores the importance of whistleblowing in protecting the public. About the Deepwater Horizon, probably many of you remember that. This was another case study where whistleblowing in engineering was not done, and as a result, the Deepwater Horizon oil spill occurred. This oil spill ruined many ecological habitats. Beaches were ruined, local economies were destroyed, and it instilled, till this day, a mistrust of the oil and engineering industry in the eyes of the public. And who are we working for? The public. In almost everything we do, it has the public is at the end of that, and they are reaping the benefits or experiencing the dissatisfaction of the behavior. In this case, this could have been prevented. This major oil spill. Think about not only the economic loss, the missed loss of trust for our profession and for the industry. The future of ethical engineering. Engineering continues to evolve. The need for ethical progress and ethical practice will remain constant. Engineers must be committed to upholding ethical standards and ensuring the safety and well-being of society. In summary, I could look at ethical practices in engineering and encapsulate what I've spoken about to this point. Ethical practice is essential to the integrity and trust of the engineering profession. Engineers must prioritize public health and safety and adhere to ethical standards and continuously engage in professional development to address new challenges. Ethical engineering practices include transparency in decision making, commitment to public safety, continuous professional development and learning, adherence to professional codes of ethics. Every decision must be made with integrity. The professional engineers, I mentioned this before and I'll state it again. The professional engineer adheres to ethical standards, demonstrates competence in their field, and is committed to continuous improvement. They maintain a high level of responsibility, accountability, and integrity in their work. They are often regulated by professional organizations or codes of conduct, and we as professional engineers are regulated by professional organizations and codes of conduct. And those I listed for you. In short, a man who walks with integrity is unwavering in his principles, acts with honesty and fairness, and earns the trust and respect of others through consistent ethical behavior. Let's go over some stories to consider. A subsidiary of a large company finds that X-ray wells failed inspection because of poor quality work. High-level executives brought this fact to the chief engineer, who was a PE. Now, we're talking about high-level executives. This is like executive vice president, and the chief engineer was nothing more than a vice president. So they bring this information to the chief engineer, and they request the chief engineer to waive the requirement for X-ray quality wells on this job. And the chief engineer knows he has the authority to waive it. However, he disagrees with the practice because he says this is going to be disingenuous to our customers if I just waive it and we don't tell the customers of this, etc. Now, this was a high pressure situation, very similar to what happened with the space shuttle Challenger. There was significant pressure being put on this chief engineer to just waive the requirement for the X-rays. Now, there was considerable pressure put on this chief engineer. The chief engineer feared for his future of his job, but at risk of losing his job future, the chief engineer refused to declare the wells acceptable. The chief engineer clinched his eyes as the CEO walked in. Now, the CEO was also a professional engineer. As the situation was explained to the CEO, he nodded his head, understanding the dilemma. The outcome of this job meant bonuses for not only the executives, but also for the CEO. Let's take a look at what happened. What happened, the CEO pondered with a long pause and said, I'm in agreement with the chief engineer. We cannot pass off these wells as meeting specifications. We will do as Tylenol did. Some of you may remember when Tylenol had a contamination of their product, they took everything off the shelves. When they took all their products off the shelves, and they could not until they could find out what was contaminated, what was not. So the CEO said, none of these jobs will be released as acceptable. We will hire a non-biased metallurgist to determine which wells are fit for service and which are not. We will advise the customer of the change from X-ray quality to fit for service quality, and pay whatever consequences are required. Did ethics prevail? At the risk of losing year-end bonuses, the CEO, a PE, backed up the position of the chief engineer, who was also a PE. A highly credible metallurgist was called in to certify which wells needed to be repaired or replaced and which could be classified as fit for service. The engineering work was fully transparent as the customer was advised of what had happened and the resolution of the situation. Another story for consideration. Friday afternoon at a process plant. A process plant might be an oil refinery or an LNG facility or some other petrochemical plant or some other chemical processing plant. To have the plant ready for Monday startup, the superintendent of maintenance was given an order to get the plant ready for Monday startup. Operational personnel would start up the plant, but significant amount of maintenance had to be performed on the plant. In order to get that maintenance performed, the maintenance superintendent needed 60 maintenance personnel to work in that plant on a Saturday. This was a Friday afternoon. At 1 p.m., the maintenance worker union delegate approached the maintenance superintendent and told him, no one will work tomorrow unless you put in an hour and a half for every hour they work. The hourly rate was already going to be time and a half, and this would have made the hourly rate double time and a quarter. Doing this would have required falsifying work documents to claim that people were working extra hours when they in fact were not. The union delegate reminded the maintenance supervisor that a week earlier, the maintenance supervisor boss had been demoted because of a project that was sabotaged, and that he had a lot of power to cause harm within the operation. The union delegate also reminded the maintenance supervisor that if the plant was not ready for startup on Monday, he would likely lose his job. The maintenance superintendent still refused to agree to the delegate's demands. So what happened? At 1:30, the union delegate told the superintendent, okay, it's your job that'll be lost, and walked out. 2:30 came. The maintenance superintendent called his wife and said, it looks like I'm going to be fired Monday because of this situation. The period from 2:30 to 2:57 was extremely tense for that superintendent. He sat in his office and the clock moved ever so slowly. At 2:57, one of them, and 2:30, at 3 o'clock, they all go home. But at 2:57, one of the mechanics called the maintenance superintendent and says, I'll work tomorrow and I'll get paid for actual hours worked. Immediately after that, all 60 workers agreed to work the following day on standard overtime rules. So the question here is, did ethics prevail? Let's think about this. Let me just get myself a lozenge. Let's think about this. Did ethics prevail? This is a kind of a subjective call. The superintendent certainly made the right call that he would not succumb to falsifying records, but did he go far enough? He did nothing to end this abuse of power by the union delegates. To others, maybe others were being, maybe his predecessors had and the people that were in his job earlier were oppressed by this kind of abuse, and maybe other superintendents or others within the company were being subjected to this kind of pressure. So he perhaps should have taken this further to the labor relations board within his company. That doesn't mean he would have gotten support by them, because maybe this was a condoned practice. But this is certainly a subjective call, and I bring it to your attention. He did the ethical thing in a very private way, but maybe he should have taken a step further. And we'll talk about more of these step further issues. Another story for consideration. Several professional engineers were working on a job to evaluate which alternative needed to be made for major process improvement. It was understood that the client favored one of the specific technologies. So let me paint the picture for you. We have a consulting engineer working with a group of other consultants, and they are tasked with identifying which project had the best cost benefit analysis. And the client essentially told him, I really like this project, Project A, let's call it. So let's see if Project A can meet the muster this for this decision. And as they went along, the professional engineer noticed that Project A was only charged about 10% of its real cost. So he brought that up and said, we cannot put this in our evaluation because the wrong costs are being shown here. What happened is he brought this up, and everybody knew that the client wanted option A to come out as the winner. So what happened here, eventually it was disclosed after a deeper dive that 90% of the client A work needed to be done anyway because of the of code compliance requirements. So then it was justified to charge only 10% of that project towards this evaluation. However, the PE insisted that it be disclosed within the report, and because of his insistence, it was disclosed. Did ethics prevail? As a professional engineer, the engineer who questioned the wording in the report feared not to meet the client's expectations. However, his concern for ethics was more important. He insisted on making sure that the values were clearly spelled out, and the ethical out was doing the correct thing, the ethical thing. His insistence on making sure the values were clearly spelled out was the ethical thing to do. Fortunately for everyone involved, it so happened that the numerical values were justified as due to a coincidental need for the project to have code mandated work being done, which means that if they didn't select that project, 90% of the work would have had to be done anyway because it was required by code. The PE acted in an ethical manner in this case. For another consideration, let's look at this story. A PE was in charge of construction activities. As a side job, he decided to own a equipment rental business. He ensured that his construction activities always rented equipment from his rental company. Since he was the sole person in control of the construction activity, this went on for years. This enriched the PE, but raised the cost of the final construction project as to the end users. What happened? A random audit was made by corporate auditing, and the scheme was discovered. The PE, along with others that were part of the scheme, were fired. It is unknown if the PE was ever brought up for professional engineering discipline charges. So you see what happened here. Here's a person in charge of a major construction activities at a company, and he decides to, either he or his wife or some entity that kicks back benefits to him, decides to have a rental company, and he ensures that that rental company rents equipment to his company so that he in turn gets a kickback and benefits by doing that. Well, this is certainly unethical practice. He in turn was fired eventually, but many years took place. Now, did ethics prevail? Well, clearly the PE being fired was the ethical thing to do. However, the PE's unethical behavior had raised the cost of projects. It was many projects over a period of time, which raised the cost to the end-use client. To be fully ethical, cost reparations should have been made to the end-use client. And that's my opinion on that particular case. And it was relating to you particular cases. Further, to avoid the behavior of the PE who was fired from being repeated in the future, the event should have been reported to the Professional Engineering Ethics Board that's affiliated with the state for his organizations. The NSPE would not really be able to take action. However, they can certainly highlight this to the board that gives licenses, and that would be a state board. Another story for consideration. A engineer, this is a relatively new PE. He's new in the company. He's a professional engineer, and his work over the last 2 years gets honored by the company because they send him to a business event that's considered a nice business event, one that he could take his wife to and charge her expenses as well as his expenses to the company. He gets back, he's working for a few days, and he gets called into the manager's office. Now, at that time, the manager's office was no one gets called into the manager's office unless it's for something severe. Gets called into the manager's office. The manager says to him, sit down. The PE sits down, nervously knocking his knees. The PE looks at the manager. As the manager takes the PE's expense report, turns it around, pushes it in front of the PE, and says, this is your expense report. I found some irregularities with it. So the PE looks at the report and says, yeah, that's the report I submitted and everything. And you're making everyone look bad. So the PE looks at the report and says, well, that's what I spent. And the manager pushes it in front of the PE and says, change it. And the PE says, I really can't do that. And they go back and forth a few times. And finally, the manager says, okay, get out of here. Well, that PE goes back to his office, continues his work. And for the next 2 years, is not sent on any trips where he could benefit both professionally and educationally and enjoy the trip. So let's take a look what happened here. The manager did not act with ethics, but the employee did. And he experienced a little negative backlash for it. Did ethics prevail? Clearly, the PE did the ethical thing by refusing to falsify company records under the pressure of a much higher management authority. However, the action of the much higher authority, the action of the much higher management authority was an error because he was also a PE and should not have been encouraging his subordinates to do unethical acts. Uh, Further, should the low-level PE have reported this event to, let's say, corporate auditing? I'll leave that for you to consider, but the ethics sometimes is a gray area. Certainly here, the junior professional engineer did the right thing, but the higher level manager did not. Another story for consideration. PE was in charge of a large number of construction projects with various contractors performing the work. Each of the projects was being overseen by an inspector. The inspector would visit the job each day at various times during the day and confirm the quality of work and determine which items were to be legitimately billed and which were not. One day, the inspector comes into the office of his manager, who was a PE, and tells the manager that the contractor superintendent, had handed him an envelope. When he looked in the envelope, it was full of $100 bills. Eyebrows were raised. The inspector did not count the money, but as soon as he saw the envelope was full of $100 bills, the inspector gave the envelope back to the contractor superintendent and told him he could not accept it. Again, the contractor pushed it in front of him, and the inspector said, no, I don't want any part of it. The inspector went back and told his section manager, and the section manager said, you did the right thing. The inspector suspected the money was intended by favorable billing decisions. The PE supervisor of the inspector commended the inspector for doing the right thing by not accepting the bribe. Did ethics prevail? The PE did the right thing by commending and thanking the inspector for doing the right thing. However, the PE fell short in not advising other authorities in the company that such practices were taking place. If the contractor did this with this inspector, it is likely that he was doing it with other inspectors, some of which may not have been giving the money back and refusing it. So perhaps the PE should have brought this up to the auditing department or to other authorities to make sure that this practice was stopped. Certainly, purchasing, if they are working ethically, would not have agreed to contractors doing this. Legal violations are also ethical violations. A newly hired PE works for a company in a new work environment where there is sexual harassment and racial comments were a common and accepted practice. Now, you know the pressures of being new in a job. You kind of want to blend in. To blend into the company culture, he takes on the same practices and allows his direct reports to sexually harass employees and to make racial comments. The PE is violating not only the law, but also the PE code of ethics. That's something to be conscious of here. When designing a new bridge structure, a PE reviews the calculations made for the foundation of a bridge built by his company almost 20 years earlier. So here's an engineer they're going to be designing a bridge foundation, and they look at other work that they've done to see how they designed the last bridge. The PE goes through the calculation and he finds that the calculation of the original bridge, the one that's already built and been in service for 20 years, that there's an error in that design. And the person who made that error is now his boss. He multiplied by a factor when he was supposed to divide. Unfortunately, this was done in the very early stages of the job, and thousands of hours of engineering were performed based on those initial values. What happened? The result is that the actual safety factor for the bridge is less than what was required by code. The PE brings this to the attention of his boss. The boss is the one who made the error 20 years earlier. And the boss tells him, just cover it up and forget you ever saw it. He says he then tells him the bridge has been standing for 20 years and it will continue to stand well after we are gone. He's saying this with the understanding that the safety factors are factors of safety, which are way and well above those that are required for design. The PE feels like drops the issue. Now, did ethics provide? Canon number 1 of the NSPE Code of Ethics is to hold paramount the safety, health, and welfare of the public. The PE that discovered this mistake has an obligation to protect the public, even if his boss overrules him. The PE that made the mistake has an obligation to reveal his error and make sure corrective measures are taken to ensure the public's safety, and even if it cost him his job. In this case, ethics did not prevail. Violation of the second law of thermodynamics. This was an interesting one. A young engineer was made manager of research and development. His background was very theoretical. It was not well versed in the business culture of the company. He attended a consortium meeting on a project that was in its 5th year and had just passed $20 million of funding. His company was one of 5 members of the national consortium. The presenter reviews the targets for the project. The PE does a back of the envelope calculation and cannot duplicate the presentation value without violating the second law of thermodynamics. PE raised his hand and asked why he comes out with a different target number. The presenter states that he's been using this target number for the past 5 years and that he would not waste his time to get this new manager up to speed. He tells the manager to go back and do his homework. He then tells the manager, I'm a PhD. How could you question my work? The new manager, who felt very intimidated, was the least senior in the consortium. And all others in the consortium were vice presidents, and he was just a manager. The PE then, feeling very intimidated, sat down and said no more. The PE went back to his office, and the executive vice president called him in and shouted at him that the president of the other consortium members called him and said that this new manager was trying to undermine the project. So the PE explained, well, it violates the second law of thermodynamics. And the executive vice president shouted him out of his office and says a six-member team will be formed and you're not going to be on it, and they will evaluate this project. Well, 6 weeks later, the project was canceled, and the research manager, the PE, was proved to be correct, but that didn't help the executive vice president, who always held him as being very annoyed with him because it was embarrassing that the executive vice president, under his watch, $20 million were wasted and 5 years of research were down the tubes. Did ethics prevail? Well, the PE manager was being a faithful agent for his clients. This research was being funded using public funds, and thus questioning the viability of the project was protecting the public's welfare. Thus, yes, ethics did prevail. Unfortunately, having the executive vice president angry was likely not the best for his future advancement as the PE manager. He ended up being a manager for another at least 10 years before he ended up getting a different executive vice president. The fundamental canons of the NSPE are shown here. We reviewed these before and look back on some of the things we reviewed, and then we're going to look at more case studies. Hold paramount the safety, health, and welfare of the public. That's number one, and everything else feeds up to them. Perform services only in your area of competence. Issue public statements that are truthful and not misleading. It doesn't necessarily have to be a lie, but they can't be misleading either. Act as faithful agents for clients. Avoid deceptive acts. Operate by conduct that enhances the honor and reputation of your profession. Let's take a look at canon number one. Hold paramount the safety, health, and welfare of the public. While visiting a structure, in fact, I remember reviewing this case. While visiting a structure, trying to remember the name of the hotel, of the skyscraper, designed by her engineering firm, a newly hired professional engineer comes across a flaw in the original design of a skyscraper. She evaluated it and realized that without cross members, the building would collapse under high wind conditions. At the cost of many millions of dollars, cross braces were installed on each floor. So that was it. That was an example of a professional engineer raising the concerns of a poor design, the company acknowledging that poor design and making repairs to remediate the poor design. Canon number two, perform services only in areas of competence. A seasoned PE boss retired, and the PE was just promoted into the job as manager of engineering. The practice was for the manager to stamp and sign off on designs issued by engineering. The newly promoted PE realizes that he was not competent to stamp and sign off on civil, instrumentation, and electrical designs, since his area of competence was solely in mechanical process and structural designs. To complicate matters, some of the engineers who performed the civil, electrical, and instrumentation work were not professional engineers. Upper management was not pleased with the new engineer's unwillingness to sign off on projects outside his area, since the prior filler of that job used to sign off and stamp those drawings. However, this was outside his area of competence, and he was not going to violate his code of ethics. It would have required the having PEs for civil, electrical, and instrumentation work in the company's employ. The company ended up hiring professional engineers to do the stamping until they could hire full-time engineers. Those consultant engineers had to review the work, had to feel competent within of the work that was performed, and had to essentially almost re-engineer the work to be competent in it, and then provide the stamp, the engineering stamp, and sign off. The manager of engineering remained in that job for the next 20 years until his retirement, never received another promotion. So maybe there was a little payback, but that's the cost of being ethical. It's part of our profession. You need to be ethical first, and your advancement within the industry. Hopefully, you're working for an ethical company and they respect that ethics. And if you're not working for an ethical company, then maybe you need to reconsider where you're employed. Issue public statements truthfully. An engineer was presenting an annual state of the infrastructure to a large audience of stakeholders. When asked about if all areas in need of reinforcement had been fixed, he responded with these words: all areas in need of reinforcement have been addressed. And that implied that, oh, they've been fixed. His boss was a PE and manager of engineering. He knew that this was not true, and after the presentation, he asked what the engineer meant by that statement. He was hopeful that maybe they were addressed and just he was not aware of it. The engineer replied, this is the engineer that gave the presentation, saying, the word addressed means we know where they are, not that we have fixed them. The engineer said, the engineering manager told him that was a misrepresented statement. It was intentionally misleading and in violation of canon number 3. Although the engineer who made the statement was not a PE, his manager, who was a PE, was complicit in the statement unless he had it retracted. When he realized the gravity of this situation, he met with the CEO, which was a little bit of a conflict. The CEO had told the engineer that made the presentation if that question from the manager and the CEO. Eventually, they came to an agreement, and the CEO allotted extra monies to bring everything up to the proper reinforcement. It would take $1 million a year for 3 years. That was agreed upon. Then the PE went a step further and made sure everyone who attended that meeting understood the misstatement or the misleading statement about the reinforcements being addressed. Family affair. This is a situation where the procurement executive is a professional engineer who receives bids for constructing a $5 billion, that's what a B, $5 billion petrochemical plant. Many parameters were weighed in order to award the bid. When the bid weighing was complete, the winning bid was given to a company named ABC Incorporated. The majority stakeholder for ABC is the procurement executive's sister-in-law. In fact, the procurement executive gave ABC Inc. the standard list of requirements for getting on the bidders list. What ethical considerations must we consider regarding this family relationship between the procurement executive and the ABC Incorporated company? As for giving ABC Incorporated the requirements to get on the bidding list, there should be nothing unethical about this if the information is public domain information, and it was. So giving someone public domain information, there's nothing wrong in that. If any bidder comes and wants to know that information, you can point them in the right direction and give them that information. As for the family relationship, at the very least, the head of procurement should make his relationship known to the company ethics officer as soon as it is known that ABC will be even bidding on the job. If the company does not have an ethics officer, then it should be made to the company's executive committee. Here's where it gets a little cloudy. Err on the side of being ethical, the procurement officer needs to avoid giving even the appearance of a conflict of interest. Therefore, once the ABC Inc. bid on the job, it would be prudent for the procurement executive to recuse himself or herself as as part of the decision-making process in the bidder selection or on any payment decisions regarding ABC Incorporated. The procurement officer should also make his reason for recusal known to the company stakeholders. This means a public uh, acknowledgement of the fact that his sister-in-law owns the company that bid on this project. Now, here's where it gets a little bit cloudy because in this recusing himself from being part of the decision process or from being part of even that project and making that project a success, he's removing his 20 years or whatever it is years of experience from the process. That $5 billion job will now be performed without having his expertise. And he will be working on other projects where he gives his expert expertise and decision making to those projects, but not to this one. So you can see where it gets a little cloudy. In order to keep him out of being unethical or keep him away from being unethical, he needs to recuse himself from this project work. What suffers? The stakeholders suffer. Either way, the stakeholders suffer because now the job gets done without his expertise being applied. However, it's a catch-22. You'd have to at least acknowledge or give notice of the fact that you are related to the person that is bidding on that job. So this process gets a little bit more difficult or more cloudy when the relationship becomes more distant. What if ABC Incorporated is a second cousin, or just a fraternity brother, or a neighbor? Becomes a judgment call where you should at least make known your relationship to that individual. Let's consider another story. Act as faithful agents, canon number 4. Act as faithful agents for clients. A PE working for company ABC shares proprietary information with his brother about the work done for various clients. His brother works for a competing company. As soon as I say proprietary, that's a no-no. Shares proprietary information with his brother. Proprietary information is called proprietary for a reason. Company ABC, that's the company he works for, wonders why their competition always comes up with the very same improvements at the same time. They do. It's obvious because they get a heads up from the brother as to what's being done in company ABC. There are two issues to consider here. The PE is not being a faithful agent because he's giving out proprietary information. The PE should disclose the fact that his brother is working for a competing firm. So those are two issues that need to be concern here. Canon number 5, avoid deceptive acts. A PE is applying for a job. She states she has a PhD from a specific university. In reality, she actually started but never finished her PhD studies. So right there's an unethical statement. She also exaggerates her role in many of her experience statements. For instance, she lists herself as being the lead commissioning engineer on several projects, when she was only one of the assisting engineers. She gets the job and no one ever follows up on those details. She has been deceptive. So this violates canon number 5, avoid deceptive acts. Canon number 6, conduct that enhances the honor and reputation of the profession. PE is known for his ethical behavior at work. He considers his ethical conduct at work to be his strong point. However, every time it comes to re-register for his professional engineer license, he states that he has completed his continuing education requirements, when in fact he has not. I'll leave that one for you to decide. It's pretty clear. Thank you for your attention on ethical practice in engineering. Ethical practice in engineering is vital for maintaining the trust in the profession and ensuring the safety of the public. Let us continue to prioritize ethics in all areas of engineering service. We're not over. Of course, I got many case studies to talk about. Let me now take a look at I want to know if you can share I'm going to do a stop sharing and then I'm going to give everyone take 5 minutes because we are at that break time. And then we're going to look at some engineering case studies. Take 5 minutes while I readjust my screen. There it is. Will someone confirm that the text in front of you says Takata airbag failure? You need to do it in the chat or Hisham, if you're there, you can let me know. Oh, I see it there in chat. Let's see, there's five things in chat. Yes, 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 yes. Okay, great. I appreciate that. It's there. All right, let us take a look at the next item, which is, whoops, I did the wrong thing there. Let me get out of that. There you go. Get off of this one. There you go. Here are some examples of ethics failures that have caused significant damage to companies as well as people. Of course, that's the public safety is the main issue. So we'll talk about some of the cases that have occurred. In 2014, the Takata airbag failure was widely reported in 2014. This resulted from using unstable ammonium nitrate as a propellant. For those of you who may not be familiar with airbags, use an explosive propellant within the airbag. As that explosive propellant is discharged, it gives off hot gases. Those hot gases fill a bag, which then hopefully it inflates before the person hits the front of the dashboard or the steering wheel, etc. Typically, there's a sensor inside the crumple zone of the car, and when that sensor senses an impact, it triggers the inflatable bag. Unstable ammonium nitrate is the propellant that was used. It exploded with excessive force. The Takata recalled Takata delayed recalls and misrepresented data, prioritizing profits over consumer safety. And that's what you see in most of these cases, profits over consumer safety. That comes up in some of the examples that we mentioned with the space shuttle, the Challenger we mentioned. Profits, meeting deadline, meeting expectations, all of those things become more important than the public safety. And one of the statements that was made in the Texas City Refinery report, it was an hour-long chemical safety board review. And one of the statements that the analyzer made, analyzing the event, was if you think safety is expensive, try an accident. And that certainly proved out to be the case in the case of the Texas City Refinery and in many of the other cases. So if you think doing the recalls are expensive, think about what your reputation hurt is to your company when you don't do the recall and then be forced into doing a recall. Over 100 million vehicles were affected, and more than 20 deaths were directly linked to the defective airbags. This is a stark reminder of the importance of maintaining ethical practices in your manufacturing process. And this 2006, when I was working in Boston when this occurred, and I remember when this occurred, there was a collapse of the ceiling in the Big Dig. And for those of you who may not know what the Big Dig is, in Boston, there was a massive infrastructure project where the traffic was actually routed underground for a significant period of significant length of the highway. So traffic, all the utilities had to be moved. Massive, massive undertaking. And they found that they used substandard epoxy when they were securing the bolts that held the ceiling in place. Part of the ceiling collapsed, and one motorist was killed. And this highlighted the need for stringent project management protocols and continuous monitoring to ensure public safety. So this was a matter of kind of lax. There were substandard epoxy being used. The key wording here is despite earlier warnings about its inadequacy. That's the key wording here, because it's one thing to discover an inadequate epoxy was in place, but it's something else when you had prior warnings of it and took no action. Let's take a look at the next one, which was the Columbia Space Shuttle. Now, I mentioned earlier to you the Challenger Space Shuttle. Challenger Space Shuttle was in 1986. This one happened in in 2003. And this is where a piece of foam insulation broke off of the fuel tank and damaged it was damaged during loss, and it damaged part of the space shuttle's heat shield. Despite engineers raised concerns, NASA management failed to address the issue adequately. This had been brought up on other prior events where a space shuttle took off and foam broke off and could have damaged, but didn't. This time it did damage. So the prior times when this was raised, it was ignored. This tragedy claimed the lives of 7 astronauts, illustrates the dangers of organizational pressures overriding safety concerns in engineering. NASA's culture of risk tolerance and schedule pressures played a significant role in this disaster. Let's take a look. We probably all remember this one, the Concorde Air France flight 4590 crash. That occurred, I believe it was in France when it occurred. It was a takeoff. While the plane took off, there were 113 fatalities. This occurred in 2000, and it was caused by a chain of events. The key wording here is engineers and aviation authorities had previously identified risks related to the Concorde's fuel tank, yet no substantial corrective measures were implemented. And you hear about a lot of the recalls today or the events that occur with some of the airlines or specific airplanes, and you hear them being put on being taken out of service, and that there's pushback for being taken out of service, and there's pushback by consumer groups, etc. And it's very much a significant input from your ethical engineers. The Space Shuttle Challenger disaster, we mentioned that one earlier. That's where it had the O-rings, and the engineers were saying you should not take off, or you should not allow this flight to take place because of the cold weather. And management overruled the engineers. The end result was the shuttle disintegrated after 73 seconds after liftoff, killing all 7 crew members. And this was a very discouraging case for the United States. The whole space industry took a hit. The entire engineering industry took a hit to some extent because it was a known defect and that was not brought to light. The Thurac 25 accidents. This was a case where software flaws in the machine, this was a radiation delivering machine, caused massive radiation overdoses. Inadequate testing and ignored prior incidents contributing to the deaths and injuries of multiple patients. So this is where they had warnings, and they had an event take place, another event take place, and they just kept allowing the machines to be out in the field and producing revenues, when in fact they should have put those machines out of service until they could correct the situation, the software error that was causing the overdoses of radiation. Okay, Chernobyl disaster. We may have seen the television program about Chernobyl, but the Chernobyl disaster not only gave a black eye to the entire nuclear industry, and think about what happened at 3 Mile Island and Chernobyl and Fukushima. No one really wants a reactor in their backyard. And one of the reasons is because of the events that took place here. Now, reactors and certainly the Nuclear Regulatory Authority has significant safety protocols in place, but if those protocols are ignored or if they are taken lightly, how many times a plant is operating and the plant manager says, do this, do that, and that becomes the rule of law, so to speak, rather than what the safety protocols dictate as the rule of law. Chernobyl disaster, one of the worst in history, resulted from poor reactor design and a disregard for safety protocols during a test. The explosion released vast amounts of radioactivity, causing widespread environmental and human health impact. 31 deaths occurred soon after the explosion, and no one really knows how many cancers followed the explosion, years and 10 years and decades later. What did this do? This really gave a black eye not only to the engineering profession, but to the nuclear industry took a big hit on this, as did with with the 3 Mile Island disaster. And those could have been avoided. In fact, just this morning, I gave a safety presentation on level control. And I spoke about how level control and has to be, and you look at the density of the top and bottom taps, and you then have a level readout. Well, several events, the Texas City refinery accident and 3 Mile Island accident, had contributing factors of improper level control coming to play. And the same is true here. If you have a disaster take place, it not only destroys the trust that the public has for you, but it gives a black eye to your industry. That's what happened with the nuclear industry. The one that really concerns me significantly is I shouldn't say, let me move this forward. There it is, the Bhopal accident. Now, this doesn't get too much press because it was not in this country, but the Bhopal accident, if you haven't seen the movie, I certainly would recommend it. It happened in 1984. The reason why this is so pronounced is that over 15,000 deaths occurred and over 500,000 injuries. And what happened here was lax safety standards, inadequate maintenance, and cost cutting. There's that big cost cutting that always save a penny and lose a dollar. Or in this case, save a penny and lose 15,000 lives and lose 500,000 injuries. Tragedy underscores ethical obligation to prioritize human safety over corporate profits and industrial engineering. Oh, human profits in industrial engineering. Think about this. Let's say you have a petrochemical plant and a lot of fuel storage at that petrochemical plant. And now there is increased development right near your plant. And now you have your fuel storage tanks 100 feet away from your property line, and there's a school being built there. Well, it's not a prudent place to put a school, so you'd have to think about that when you're putting the school there. But of course, the industry who owns those tanks says, "Why? We're safe. We're safe." But the fact is, there are certain hazards that you have to use common sense for. And in the case of the Bhopal disaster, having that accident happening near a population center without having a warning device or other risk mitigation measures was caused a significant amount of death and a significant amount of injury. The Kansas City Hyatt Regency walkway collapse. I mentioned that one earlier. That's where 114 people were killed and 200 were injured. And what happened there? There was a lack of management of change procedure in the construction. The Love Canal, and these are ones that probably prompted a lot of, oh, I remember that event being when you were born. But for me, I was well into my career at that time. Love Canal was an environmental disaster that occurred in the late 70s and early 80s. A catastrophic events of building a neighborhood on top of a toxic waste site. And this is what I mentioned before about you have existing petrochemical facilities and you build right near it. Well, you certainly, if those facilities have toxic underground, you have to take consideration before permitting those facilities to be those housing developments or schools near a waste site or near a petrochemical farm, etc. May not, that doesn't mean all petrochemical farms have toxic waste under them, but certainly if you're going to build a school or a hospital or some other place of public assembly, you want to make sure or even environmental concerns for that area. And that goes true with organizations that allow permitting for new construction. The catastrophic events were they built near this waste on top of actually a waste dump site, and effluent or not effluent, but leakage from the waste that were buried. They were in 55-gallon drums, got into the homes and got into the schools and caused a significant amount of birth defects and cancers and other diseases that were associated with those chemicals. And this is a pivotal example of how ethical implications of environmental engineering decisions. 3 Mile Island accident, I mentioned that earlier. I didn't mention it in detail. Although no deaths occurred that are attributed to the 3 Mile Island, the incident damaged the public trust in the nuclear industry and nuclear energy. Engineers failed to address known safety vulnerabilities. The key word there is known safety vulnerabilities, emphasizing the necessity for robust design, operational protocols, and high risk in high-risk industries. The DC-10 crash in Paris, 1974. DC-10 crash caused, let me get back, I missed it. DC-10 crash, here it is. In 1974, a DC-10 near Paris caused by a faulty cargo door design killed 346 people. Engineers were aware of the design flaws, but failed to implement timely corrective measures. The word timely I should have highlighted here. If you know about something, you have an obligation to correct it. And the word timely comes in. You don't wait for your predecessor to correct this, or the follow-on employees to correct this. You have to take corrective measures as soon as you know about the design flaws. This demonstrated the need for proactive oversight and ethical responsibility in engineering design and manufacturing. Let me see if I missed one here. Yes, I did. Actually missed two of them here. Okay, the Citigroup Center, and this is one I brought up to you earlier today, and I had said it was a PE who found the flaw, but in fact, it was a engineering student. A design review prompted by an engineering student. I believe the engineering student was an intern at the company, led to an emergency retrofits. This was a near miss. This was the Citigroup Center. I didn't mention the name of the building because I forgot it, but here it is. It's the Citigroup Center. This occurred in 1978, where an intern working at the company was reviewing the engineering designs and came across this error in design that under high wind conditions, this building could have collapsed. Well, she brought up the concern to her management, and her management ran with it and made the repairs at the cost of millions of dollars and significant embarrassment, because they had to rip open the walls on each floor to install structural braces on the structure of the building so that the building could withstand high winds. Maybe nothing would have ever happened, but the fact that it was found and repairs were made before anything was a concern, that was certainly a prudent engineering decision. The Ford Pinto safety problems. A Ford Pinto, I mentioned this one earlier also, had a fuel tank design that was susceptible to explosions in a rear-end collision. Despite knowing the risks, and that's the key words there, despite knowing the risk, Ford prioritized cost savings over implementing safety designs or safer designs. This scandal, as it was referred to, underscores the ethical obligation to prioritize human lives over financial considerations in product engineering. 27 deaths were linked to this problem. Profits over safety. That's where a lot of companies run into problems. Profits or schedule over safety. And a lot of times, schedule has to do with appearance, how you look to the client. So you have that concern. And Challenger, the a deep sea high water horizon, and so many others, the Pinto, many other projects all came down to cost versus safety. The Chevy Corvair safety problems, rear suspension flaws made it prone to dangerous instability. This serves as an example of ethical obligation for engineers. This won advocacy by Ralph Nader. Many of you may have heard of Ralph Nader. He was a consumer advocate in the 1970s, and subsequent investigations revealed a lack of commitment to safety on the part of Chevy. This case emphasized the necessity of ethical responsibility in automotive engineering. The other one I pointed out was automotive engineering, was the Takata airbag corrective action. Cleveland East, Ohio gas explosion. That's an old one, 1944. But why I remember it so vividly, not that I was here in 1944, but it's part of my training that I give to LNG engineers. 1984 accident was due in part to using wrong engineering, not evaluating materials properly before using them, and taking shortcuts. And this these tanks were built during 1940s when the country was at war. They used 3.5% nickel steel for the construction of the inner tank, which held cryogenic liquefied natural gas at minus 256 degrees Fahrenheit. Well, at that temperature, you need 9% nickel steel, not 3.5% nickel steel. 3.5% nickel steel is only good to about minus 150 degrees Fahrenheit. So what happened is the steel became brittle. It experienced a small crack, and the crack ran, and the entire tank collapsed. The cryogenic liquid hit the tank next to it, which caused the structural steel, which is not cryogenic, to have the second tank collapse. And without impoundment around the dikes, around the tanks, the LNG ran down the street, ran into the sewers. The sewers, water seeing LNG rapidly caused the LNG to vaporize, pressurize the sewers, caused explosions in multiple houses as the sewer pressurized and blew gas into buildings in a large, I forget how many square blocks it was, maybe a 10 square block area. One sewer cap was found a mile away from where the explosion took place. So you could see the sewers were exploding, buildings were exploding, and there were, I forget how many lives were killed. Oh, here it is, 130 lives were lost. And I think it was something like close to 600 people were displaced. So they had a lot of people left without livable quarters after this had occurred. This was in Cleveland, East Ohio gas, and that happened in 1944. And very similar to the Titanic, poor materials were used for in this case, it was for the cryogenic tank. And now I mentioned Titanic, here it is. In 1912, this is an early one, but this resulted in over 1,500 deaths, and it exasperated by engineering and design flaws, including insufficient lifeboats. Again, we talk about cost versus safety. Insufficient lifeboats. Why would you put insufficient lifeboats? Because the less lifeboats you have to carry, the more people you can carry, the more money you can make. Why were the separating areas not as high as they were originally designed? Because it was a cost-cutting measure. The rivets that were used to bolt the plates together were not good down to 32 degrees Fahrenheit, and the water that they were in the North Atlantic was down to 31 degrees Fahrenheit. It's actually below freezing temperature, water freezing temperature, but the salt in the water allowed the water to be at 31 degrees Fahrenheit. And the rivets then sheared off on the brittle failure because they were not the right material for that service. The Deepwater Horizon oil spill. This is one of the largest environmental disasters, and most of us could probably remember that one because it was only 15 years ago. It was one of the largest environmental disasters in history. It This was caused by ignoring critical safety warnings and using substandard cement to seal the wells. Cost-cutting measures and a lack of contingency planning exacerbated the disaster. This disrupted significant ecosystems and the economic health of the Gulf, of the North Shore of I should say, the South Shore of the Gulf states. And it also affected, of course, Mexico as part of that, and also the other islands that were affected. They ignored critical safety warnings and used substandard materials. The Rana Plaza collapse in 2013. This killed over 1,100 workers, caused by structural failures and negligent practices. The building was constructed with substandard materials, and additional floors were added without proper engineering and oversight, This tragedy highlights the ethical failures of engineers, construction firms, and factory owners who prioritize, again, profits over human lives. So this is and these are ones that you can just jot down, and then you could always look up these events and see what took place, look at the details of it. For each one of them, you probably find multiple pages on the internet. Volkswagen emission scandal. I remember this one. Uh, Volkswagen emission scandal uncovered in 2015 revealed that the company had installed software in its diesel vehicles to cheat the emissions testing. This was an intentional software installation. This deliberate act allowed cars to pass regulatory tests while emitting pollutants far above the legal limits during normal operation. So this was okay, instead of let's be safe culture or let's be environmental correct culture, this was a check the box, pass the test culture. We have to pass that test, so let's design our equipment to pass the test, not to meet the environmental standards that the test was intended to enforce. This is a stark reminder of ethical obligation of engineers and corporations to uphold transparency and integrity in product design and testing. The Fukushima Daiichi nuclear disaster. This disaster resulted in over 100,000 being evacuated, mainly elderly, some of which died caused by stress of evacuation during the relocation. The disaster highlighted the importance of proactive management and ethical responsibility of engineers and policymakers to provide safety in the face of known threats. Building in an area where tsunamis are somewhat common, where earthquakes are somewhat common, you need to take preventive action to make sure that there are measures taken to make your facility safe. Now, it's interesting. After the horse is out of the barn, we always do things. So I remember reading about nuclear power plants in Japan after this event had occurred, how they had to install these very high, very robust seawalls that were, if I recall correctly, 30 feet high and could withstand a tsunami type of surge. And it was like a mile long in front of the plant so that the plant was protected. And these were required for the coastal plants that were that were in Japan, that were in a earthquake or tsunami prone areas. And I'm thinking of one in particular that was south of Tokyo that I was reading this article about. So those are the type of things that we do after the fact occurs, but before it occurs, we should be able to say, as ethical engineers, we need to prepare for this event, as unlikely as it might be, or as likely as it might be. If someone says we have a one in a hundred year storm, well, that storm could occur next year. There's no reason that we don't prevent against that. Now, you have to use common sense risk analysis, of course, but some of the risks that I've pointed out were clearly known by the companies as being non-acceptable risks and were tolerated. The Grenfell Tower fire of 2017. In this fire, some 72 people were killed, and it was fueled by flammable cladding and insulation materials used in a recent refurbishment. Well, engineers, contractors, and building inspectors failed to ensure compliance with fire safety standards, and residents warning about safety concerns. These were ignored. The tragedy revealed the systemic failures in construction and regulatory processes. And all too often, we get comforted by the fact, oh, we have a safety protocol in place, and we forget to engage the brain and use common sense on certain things. So we say, oh, well, the safety measures were applied. I remember being at a job site where a person was saying, okay, if we have an emergency, everybody muster to this location. I was on a gas site, natural gas site. And I tapped him on the shoulder and said, that location is downwind. He said, oh, you want me to change? I said, yeah, have everybody muster upwind so that if there is an event, we don't all muster where the gas is flowing. So he changed it. Okay, we're going to change that. We all muster upwind of the potential gas release. And why was that important? Because you have to engage the brain before you proceed with a project. It's not just check the box. Well, I had my safety briefing and I told everyone the muster location. You have to use some common sense in selecting those muster locations. I want to tell you about one other that's not listed here. Yeah. In 1973, an LNG, that's liquefied natural gas tank, was being repaired in Staten Island. I happen to live in Staten Island. I happen to live 3 miles from the location of where that plant was. And I say was because after this accident occurred, the entire site was bulldozed flat. And if you look at the site today, you'll never realize there was ever a tank installed there. And the tank had been decommissioned. That means taken out of service. All of the energy was taken tanks. All of the vapor, the gas vapor was taken out of the tank. And for 10 months, it had no LNG in it. And then there was an explosion in the tank. 40 workers were in the tank. Actually, it was 43 workers. All 43 workers were killed. Here's what happened. There was a fire inside the tank that grew so rapidly. A rapid deflagration is what it was called. Well, you can the terminology called an explosion or not. Rapid deflagration is the technical name that was given to it, which caused the inside of the tank to pressurize, raise the roof, which was a concrete roof, and then the roof collapsed in on the workers that were in the tank. I have a picture of that as the helicopters flew over, and all you see is tremendous thick black smoke billowing out of that tank. Well, everybody was either overcome by smoke or crushed in the collapse. So that's what killed the 40 workers, 43 workers. What happened after that? Well, it caused an outrage within the state government, and all LNG projects were banned in New York State for it was banned up until 2015. So think about that, 1973 to 2015. Also, what happened, New York City banned the trucking of LNG within the city limits. So now what happened? You have now trucking being banned. So the entire LNG industry took a hit for this, certainly in New York City and certainly in New York State. In fact, even though after 2015 the ban was lifted, it wasn't until after 2000, I think it was 21, when they put in place code allowable allowances for new facilities to be built in New York State. So you could see what it did to the industry. 20, 50, since almost 50 years, shut it down within New York State. And certainly it's still shut down today that you cannot truck LNG within the city limits here. Now, what impact did that have on the LNG industry? About 3 miles away from that location, I said the location is about 3 miles from me, and less than a mile from me, there's another site where two LNG tanks were installed. They were fully constructed. All the construction was complete. All the equipment was in place. And what happened is because of the accident that happened 3 miles away, there was strong, significant public pressure against these tanks. A group by the name of Blast Bring Legal Action Against Tanks was formed, and they got the local government to revoke the operating license from these two tanks that had just been built. Their commissioning cargo was en route to those tanks at that time. So not only this was an import terminal, importing ships from overseas carrying LNG into Staten Island. That tank, once their operating permit was revoked, those tanks and all the equipment on site, this was a big project. It was probably the largest LNG project in the United States at that time. Well, that plant was shut down, never saw a drop of LNG. So think about what that prior accident did to the LNG industry in New York State, in Staten Island, in New York City, and across the nation. So this concludes my presentation on ethics and on ethical practice. We have a couple of minutes. Any questions that I might be able to answer? And I can't give an ethics decision on your particular company or event, but I can tell you I've given you the guidance that the NSPE has spelled out and the guidance that the National Council of Examiners, Engineers, and Surveyors has spelled out, and the guidance from the accreditation board, the ABET, ABET organization. And I've given you some case studies to be a guide. Are there any questions that you might have before we go into the exam? Thank you for your listening through this presentation. I encourage you to use EnSite for continuing education in the future. They are a premier provider of continuing education. And now I'm going to turn it over to the EnSite coordinator, who will give you the exam on this course and tell you how to get the professional engineering credits for this course. Hisham, can you take over?
Yes. Please see the note in the chat about how to get that quiz and certificate. It's straightforward and easy. Just log in, do it. I am posting the note in a minute. Right now.
Are you talking to me, Hisham?
Yes, I'm talking to everyone. And the note is in the chat box. You can log in and get the quiz. Thank you.
Okay.
Did everybody get the note? Please type in the chat. Yes, you see the note I just posted. I don't know if you can hear me or not, but my mic is on.
Yeah, I hear you.
How about now?
I
Anyway,
hear you.
tell them it's in the chat box. Is the note in the chat box? Tell them how to get the.
He said in the chat box, what do they need to do?
We tell them how to get the quiz. All the instructions, step 1, 2, 3, how to get the quiz and the certificate.
Where is that found? Under more?
In the chat box.
Okay. Chat box.
Okay, I see people saw it. So just click the chat and you will see my note from inside.
Yeah, I see it.
And it's also the first note in the chat box way on the top. the chat box way on the top.
If I see it.
All right, thank you very much. See you next time and have a happy new year. And if you have any issue, please send us an email through the contact or our email engineer@insighteengineeringhub.com. Have a good evening.
Okay, Shisham, before you leave us, I'm in the chat box. I'm looking at thank you for your interest in the webinar. Log into the site, and it gives you, there's a hyperlink there. Is that what they have to use to get to the exam?
No, there's a link they have to go to the quiz, the webinar page, and click start course and go through the process. Step 1, step 2, as I outlined in the
Okay,
chat.
got you. All right, thank you.
Takes you to the quiz, and you start the quiz, and then you finish the quiz, you submit the quiz, and you complete the course.
Very
You will
good.
get your certificate. You can print it.
Okay, thank you very much. You have a good day.
You too.
Everyone, thank you for attending. I'm finished, honey. I don't know if anybody was able to find the exam. I wasn't able to find it. And Hisham is so difficult to understand. Hisham was so difficult to understand. Also, my voice was cracking so much. It was terrible. Yeah.